Hello everybody, DemonStorm666 here. Now, in our last episode, we actually went through the Big Bang in a very basic form, but hopefully it gave you a better understanding of how our universe was formed and created in the time that immediately followed the event whatever event it was that caused the expansion of our universe. In this episode, I want to cover how, in that thick soup of energy and matter, the first galaxies formed. Now, it is important to note that at this point in the development of the universe, that it's almost entirely uniform. That is to say that the soup, energy, and matter that makes up this primordial firestorm is almost entirely evenly disputed. Now, at this point as well, matter has finally achieved superiority over antimatter, and without that victory over antimatter, the universe couldn't form into what we see today. Now, over time, clumps of dark matter would form in the more dense regions of the universe, as it is this soup of fiery matter and energy. And this would lead to the surrounding matter being gravitationally attracted towards the dark matter. Now, this formed proto-galaxies, and they created hotspots in this soup, allowing the rest of the universe to continue cooling. And slowly, over billions of years, stars would start to form in these proto-galaxies, leading to the myriad of full-blown galaxies that we can see today. Now, there are many different types of galaxies that have formed since then. We've got the elliptical galaxies, and then there are the two different varieties of spiral galaxies that we can see. And Edwin Hubble spent a great deal of time categorizing these different types of galaxies. So the Milky Way galaxy in which we live is I think it's a type SC galaxy, which is a spiral C galaxy. And we have several large arms which spiral out from the center of the Milky Way galaxy. So let's take a better look at the Milky Way. The Milky Way is actually one of the big boys in the galaxy family. It's very large, consisting of more than 200 billion stars. It is believed to contain more than 50 billion planets, maybe of which 500 million are in the sweet spot in their solar systems, also known as the habitable zones. So that's about 500 million that could potentially lead to the formation of intelligent life. Now, in our galactic neighborhood, our nearest proper galaxy is Andromeda. And at the moment, that's standing at roughly about 2.5 million light years away from us. But the thing is, it's actually getting closer. It's hurtling through space in our direction, and at some point in the future, it will collide with the Milky Way galaxy. Its estimated speed is about 400 light years per million years. So it's going to get here in the future, so you don't have to worry about that. But at present, we're not entirely sure what a collision with Andromeda will do to our own galaxy, let alone our own solar system. Now, there are, as well, two dwarf galaxies that reside close to the Milky Way. They're kind of like satellite galaxies. They're a lot smaller than the Milky Way itself, and these are the Lesser and the Greater Magellanic Clouds. And we've seen in the observable universe that other galaxies similar in size to our own also possess these small satellites. Now, these small satellite galaxies, the Lesser and Greater Magellanic Clouds, only contain around 200 million stars compared to our 200 plus billion. So they are massively smaller, and they could be the result of the formation of our galaxy, basically denser spots that we're able to pull away from the actual main body of the Milky Way. A very interesting feature of our galaxy, which has only just recently been discovered, is the very center of our galaxy is a supermassive. There rests a supermassive black hole. Now, we're not entirely sure how these supermassive black holes occur. It could start off as a normal stellar black hole that has over billions of years just gained in size, or it could be from a supermassive cloud of gas that collapses in on itself. But the hypothesis is that these supermassive black holes could be part of the gravitational forces that actually hold the galaxies that we're able to observe together. Now, in the universe itself, we can see that galaxies aren't uniformly distributed like one might expect them to be, but this is a result of the irregularities that we mentioned before in the densities of the soup of energy and matter. Now, where these densities differed, galaxies formed, and thus we get clusters of galaxies strung out across the universe. Here's an example. This is a galactic cluster known as the Abell cluster. And here's another galactic cluster here. Now, if you note on the left-hand side, you can actually see that there is a galactic collision in progress there. You can see down at the bottom there's one galaxy, and then there's a little trail leading up to where the second galaxy is. And that is a collision that's in progress. It's like a cosmic ballet that plays out over millions and billions of years. But we haven't even begun to see a fraction of the number of the galaxies that exist in our universe. We've only just begun to see the wonders that our universe holds. Our minds at the moment can't even comprehend what might be out there waiting for us. The universe is so mind-bogglingly vast that the human brain just can't take it all in. It will be the ultimate journey of our race to get out there into space, and it'll be the ultimate achievement, and it'll be our ultimate destiny to walk the stars. But we can't do it until we grow up as a species. And while things look bad now, this is precisely because certain parts of the human race are starting to wake up and grow up, and they're clashing with those factions of our species that are stuck in the mud. Anyway, in my next video, we'll go through the formation of stars in these galaxies, and this will include taking a deeper look into nebulas, which are where stars are born. I hope to see you all there. Now, if you like this video, please comment, rate, and subscribe. And until my next video, I wish you all the very best.